Even in those situations where we do not have our desired form of ax squared plus bx plus c, we can utilize that trial and error slash AC method thinking in order to factor a polynomial. First, looking at this polynomial, we recognize a greatest common factor of 3r squared. That has to come first before we can do anything else. Once that term is separated and that monomial is factored out, we're going to factor it from each part of the polynomial, and we're left with r to the 6th plus r to the 3rd minus 20. Now, at first glance, you'll notice that this 6 does not match the 2 that we have up here. Clearly, if we wanted to use the AC method or something like it, we would have to say that that number was 1 and that number was 1. But we have this non-matching highest degree or degree highest power of the polynomial. So you really don't, at first glance, think you can get into the AC method or trial and error. But a different thing to recognize is that this 6 is double the power here, and this term is still a constant. When thinking about the AC method, that is actually what we want to see, because we can factor a little bit more creatively when we have these two powers being double or half of each other, respectively, and we can use the AC method in that situation. The reason that we're able to get away with that, and you don't necessarily have to remember this part as being super important, the reason that we're able to get away with that is because r to the 6th can be rewritten as r cubed to the 2nd. So really, that first variable, quote unquote variable right here, is r to the 3rd, not r. And that's what we're going to use in order to do our factoring. So because those two powers are twice one another, we can get a little bit creative with the AC method and actually use it to help us do our factoring. So using the AC method, we have a of 1 and a c of negative 20, which means when I multiply them together, I'm going to get negative 20. I have a b, which is our coefficient in the middle, of 1. So I'm looking for two numbers that multiply together to make negative 20 and add together to make 1. One of them will be positive and one of them will be negative. The positive one will have the larger absolute value, and I get my two numbers as 5 and negative 4. Rewriting my polynomial with those two new middle terms, we have r to the 6th plus 5r to the 3rd minus 4r to the 3rd, and finishing with our minus 20. We have our four terms in our polynomial, so we can factor by grouping. We look at the first group, and I see a common r to the 3rd, which leaves us with r to the 3rd plus 5. If factoring by grouping is going to work, r to the 3rd plus 5 better show up in the second parentheses, which it will, provided that I use minus 4 as my common factor. Creating our last line, we have 3r squared as the common factor. We have the shared common binomial r cubed plus 5. And we have the two common factors from each individual part of the grouping, r cubed minus 4. We check to make sure that neither one of these two polynomials is the sum or difference of a cube. Neither one of them, or a set of cubes, neither one of them is. So we have our final version of the polynomial.